Hi everyone, so welcome to my project of creating a COVID and pneumonia classifier. So to do that we have used both the hyperdrive and the AutoML model. So for now let's look at the hyperdrive models. So the hyperdrive model that was used, this was the best model that we found over there, and the best model, as we can see, had a accuracy of 97%. And these were the arguments used, where all the arguments used were actually the different number of filters in the convolutional layers and dense layers and the dropout rate and number of epochs. These were the 5 different parameters trained, and as we can see, for this particular value and a training of 25 epochs, we were able to achieve a good accuracy of 97.2 percent. So this model was also deployed, and we can see the model endpoint over here, which is running and healthy, and we can also see the rest endpoint. So now coming to making the request to it. So this is the code at our Jupyter notebook. This is where it was deployed using the ACI web service class, and once deployed we can see it was healthy. And we use two ways of sending a request to it. One is directly by using the service.run method, where this being an image classifier, an image was loaded from the existing dataset, converted to an array, and we sent it as a request to the service by using service.run. And we can see that the result was as follows. It was a COVID image, and we can see that the prediction was also COVID. And run the other way is to use the REST endpoint itself. As we can see, the ACI web service was actually deployed with authentication enabled to generate the keys, and hence we also first try to get the keys and use the keys for sending a request. So a post request was sent to the scoring URI using the same data. So the input data over here is the same as earlier, as the one we used with service.run, and we can see that with the headers and the data and the keys, the key was attached to the header, so we can see that the final output, the prediction, is achieved successfully. So as the hyperdrive had a better accuracy, this is what we deployed, and here are the results as we just saw. And coming up next, we'll look at the AutoML training. Okay, so now let's look at the AutoML model. And so I've now closed the hyperdrive tabs and kept the AutoML tabs open. And so coming to the AutoML tags, AutoML model, let's look at the settings. So these were the settings used, and the most important one was the enable DNN true. This was done because, just as how the hyperdrive used a neural network, the idea was to also enable a DNN here, so that we can have deep learning models. But at the same time, the problem was with the extensive training time it took for training multiple models, because in the AutoML it looked like first normal classifier models were used and the deep learning models came in only after that, but which resulted in a lot of training time. Hence it was restricted to just around 45 minutes, and in that 45 minutes we found that deep learning models were not used, and the only other classifier models were used, and the maximum accuracy found was with the voting ensemble model, with the accuracy of 94.8. And coming to the studio, we can see the AutoML run completed. The model that was found, the best model, as we can see, was the voting ensemble model. And when we go there, we can also see that we can also see the tags here, which shows us the algorithms that the voting ensemble used along with the weights. So with these parameters, it was found that the best accuracy was just around 94.8% or 95%, whereas hyperdrive had a better accuracy and hence it was deployed as shown earlier.